Okay, everyone. I'm doing a quick video on finding a probability given a normal distribution. Uh, I got asked this question a couple of times, so I thought I'd throw this out there. There is in my slides, it's the last, I think it's the last example in the topic 5 slides, but I don't think I do one that's either between or on the outside edges. I just do one from that value down. So I thought I'd do one that's on the outside edges. That I feel is a little bit more difficult. Excuse me. So let's get into it, and hopefully this will help you on the assignment. So here's an example. So Yodel Air operates a charter jet service out of an airport in a secluded mountain ski resort. The chief safety officer uses a normal distribution with a mean of 626 meters and a standard deviation of 880 meters to model the takeoff distance of the company's X-15 jets in wintry weather. So basically whether or not it's safe. So the question that they're asking here is you can use the table or the ALEKS calculator to find the percentage of takeoff distances less than 590 meters or more than 710 according to the model for your intermediate computations. Use 4 or more decimal places, give your final answer to 2 decimal places. And they tell you you're doing it as a percent, 98.23. Okay. So first, let's talk about what we're looking at. This 590 meters is not a nice even subtraction of 80 from this, so we can't use the empirical rule. That's the first thing I notice. Also, adding 80 to this is not going to give me 710, though it's close. So my empirical rule not as useful in this case, which is okay. We do know it's normally distributed. We're told that. So we can use the idea of z-scores, which we briefly talked about. I do know we didn't go into a lot of detail because you don't need to go into a lot of detail. So what we need to know, we need to recall is what does that find? What does a z-score tell us? Well, a z-score, when we find the probability of a z-score, we're really finding the probability from that z-score all the way down to the left. And we're finding that area under that curve. And as we established before, that area can be represented as probability. So z-score, find that value, and we have everything less than. Well, that works great for the 590 because we want everything less than 590. The problem is over here, the 710, we want everything greater than. That's okay. We know if we want all of this side, this unshaded side, I know the whole thing is 1. So I could say 1 minus my z, because that would be everything below it, and I'd be left with the unshaded part. So we can use those tools. First, let's decide what's going to be our z1 and z2. Z1, we'll just use the first term because we don't need to get fancy with it. Z1 is 590. Or the score based on 590. And Z2 is going to be the score based on the 710. We need to know how to get our z-scores. Our z-scores are fairly easy to get. We use this. We take that score, we minus our mean, and we divide by our standard deviation. We've been given our mean, 626, our standard deviation of 80. So this gives us this value. And we can calculate these values and then just use the values. I don't normally do that, and I'll show you how I do it in the calculator. But this would be great if we were having to use the tables. And then we need to get Z2, so of course we can do the same thing. Using the 710, and we get a Z2 score of 1.05. Now, with these values, we have decisions to make. We can use the table or the ALEKS calculator. And I'm going to really mention the table, but I'm going to focus in on the ALEKS calculator because it's quick and easy to do. And I don't even have to do this calculation if I use the ALEKS calculator. If I use the table, I have to. So again, remembering what we're looking for. So I need to figure out what I need. Well, I need the probability of Z1 plus 1 minus the probability of Z2. And I could use those values and I could use this messy table. There's nothing wrong with the table. I've used it, not necessarily this particular table, but the Z table hundreds of times. They're useful. But I would find my score for Z1, I would find where that is, and I would look at its value, and I would do the same for Z2, and then 1 minus that Z2. You'll notice I'm not even showing the actual correct values. This table goes on and on and on. I did not want to go through that. So what I'm going to do is I'm going to show you how to do this in the calculator. So same idea, pull that up. And we want to use the calculator to do this. And the calculator has a nifty button that we're going to focus on. And it's right here. I'll show it again. Let me move some stuff around so I can work on this a little better. So let's get rid of that. We don't need that. That's what we're looking for. Let's pull up the calculator. Okay. The button, there it is. That's our friend. That's the probability of Z being less than, just like we were already talking about and what we expect. All right, so first thing, let's put in what we know. We know this formula. I'm not putting in the number. I'm putting in the whole formula so I can just do this. This value is really my Z value. So that value is my first Z1. So there we go, whatever that comes out to be. But I'm not going to round it to 4 decimal places as I work. I'm going to go ahead and do it at the very end. Then I don't have to worry about rounding multiple times. So now I'm going to add 1 plus this. So let's do that. Let's 1 plus my Z2 score, which is the 710 minus 626 divided by the 80. Put that in over here. There we go. So this is what I've put in the calculator, exactly as I put it in. And then I'm going to hit enter, right? Because that's going to give me what I want. So we'll put the equal in. There we go. I get 0.47321427, and then it shows some sixes, which is totally fine. I do know I'm supposed to round it to 2 decimal places, but first I know it's a percentage. So I'm going to convert this to a percentage. Now, a lot of you feel you have to type in the calculator times 100, which works. There's nothing wrong with that. That's fine. I'm just going to move the decimal place 2 places over and say, well, this is 47%, 0.3, 2, 1. So this should take 2 answers. It'll take 47.32. Or if I had used the table, and which I did before, and I was going to make the video showing that, I got 47.33 with the table. So variance a little bit, but 47.32 or 47.33. That's how close this is, and it'll take both as the correct answer. Just make sure that you do write it as a decimal, okay? Or as a percentage. So you do need to write it as 47. Let's see. Pretty big. You don't need to put the percent sign because that's up there, right? 47.32. Just put that in and you'll be good to go. All right. I hope this helps. I may do one where it's between. Like I said, this one is below this, and then above this, which I felt was harder. There is one that gives you like a value here, and it wants between the two values. Um, and I think that one's easier, but I may do one of those also, just to show you. My goal in this was just to help. So I'll get this uploaded and posted, and then I will send out a message or announcement showing that I added these videos to my website for you guys. All right, that's all I got. You guys have a wonderful day and keep studying.